Using calculus, right, you're told to find the stationary point. This one here just says that it's quadrant 1. Anything, because 0 to 90 degrees, right, you just take note of that. So whatever solution you get out of this range domain, you just reject, okay? So this is fx is given by ex and x. So just be mindful, just product rule. You need to also determine its nature later on. We just look at f prime x, so ex negative sine x plus cosine x dx. Okay, so this is product rule. uv dv dx plus v u dx. Okay, then of course you could just leave it like that, or you could just factorize the ex out. I'll just factorize the ex out. Okay, at stationary value, okay, we know that f prime x equals to 0. Okay, and if f prime x equals to 0, ex is always positive, so this will never be 0. Whatever x value you give me is, so it's only this is the only one which will give me 0, right? So it's minus sine x plus cosine x equals to 0, or ex equals to 0, but you can just reject as ex is always positive. So this guy here, how do you solve this trigo equation? I think you can change it to tangent, then it's easier. That's what I see. So this guy will be sine x equals to cosine x. Then sine x divided by cosine x equals to 1. So this is tangent x equals to 1. This is x equals to 45 degrees, which is actually pi over 4. Okay. But the good thing about this question is it's only quadrant 1. So you don't need to worry about quadrant 3. Okay. You don't need to worry about ASTC because it's only quadrant 1. So that's it. Determine its nature. So they say using calculus to determine its nature, you cannot use, can you use first derivative test? Actually, that one also, yeah, you can either use first or second. But I think second is more legit lah. Okay. Yeah, yeah, I think I will use second derivative test. So just differentiate this once more. So f prime x ex negative sine x. Okay, so I am going to label this out. So this guy, I'll get this negative 2 sine x ex. You factorize the ex, you can see that the negative cosine x and cosine x can factorize it out. It's very clear because in quadrant 1, sine is positive, right? Agree? Quadrant 1, sine is positive. This is positive. So obviously, the entire thing is negative. Okay. So you can see very clearly because quadrant 1, this is positive, this is positive. So this is negative, right? So hence, the one, the coordinate, is it? Stationary point. Okay, so means I need to find my, so f pi over 4. I need to find my y value. Just replace this in e pi over 4. And this is cosine pi over 4. That will be 1 over root 2. So hence, pi over 4 e pi over 4 over root 2 is okay, that's what I'll do. So the second one is a classic example. This is by part twice, right? This is what we call like infinite loop. You just loop. Because if you take the two tail end of the liate, right, you will keep getting the same expression. So you just be careful. So part B, they say twice. That's the keyword there. So we just do this carefully. So this case here, just e 2x then 2x dx. So you just pick any one. It doesn't matter whether you pick u as cosine or e 2x. But if you're using liate, very likely you use this as your u. So u is equal to e2x. dv dx is actually cosine 2x. du dx is 2e2x. v is half sine 2x. Okay? So then you just do this by parts. uv minus v du dx. Okay, so this is u multiplied by v is this guy, minus of the integral of v du dx. So rearrange it, will be half e2x sine 2x e2x sine dx. Okay, similarly, let your u now be e2x. So u1 e2x dv1 dx equals to sine 2x. Then do the same thing by parts again. du1 dx to e2x. v1 is negative half cosine 2x. Okay. Then half e2x sine 2x minus negative half e2x cosine x 2x, then 2 e2x multiplied by half cosine 2x dx. You just rewrite it nicely lah. Let me just be careful with the negative sign when you expand and all this. So you just be very, very careful. This is overall positive, but this negative when you multiply in. This one need to expand it in. So just be careful. Now this is a classic example. If you are part of the problem and you're part of the solution, right? Then you'll confirm the problem. Such is life. Okay, understand that. So if you get this and you get yourself, you should stop, because that's why the question prompt you say by parts twice. You do by parts twice. So by the second time you should stop. So some students will just keep on going on forever. Then that's where the pain comes in, sets in. So you just see this as entity. Usually what typically we'll do is we'll just let I equals to e2x cosine 2x dx. Okay. Then you can see this is half. This entire is one entity. This entire thing is one entity. This is I. This is your I. So you know that this is like half e2x sine 2x plus, maybe I factorize it. Can I factorize it? I can factorize it. So this one sine 2x plus cosine 2x minus I. Okay, so you get 2i equals to half e2x. Okay, so usually this is what we do lah. But you can, okay, so then divide by 2 both sides. So what you get is 1/4 e 2x sine 2x plus cosine 2x plus c. Okay. The next one, you are looking at fx. So plot the graph f ex cosine x. 0 to half pi. So we're just gonna ex, which is here, sine x. Okay, now what we do is, if you want to put the domain here, you just put a divide sign. Then you just put from 0 to pi over 2. So 0. Second test, number 5 to pi over 2. Okay. Now of course you just zoom and you get this graph. So I'm gonna just zoom box inside the graph here. So pi over 2 will be 0. And 0. So you just connect this down. It's just this area here. This is y equals to this fx equals to ex cosine x, right? The required volume, you just rotate this. Required volume pi 0 to pi over 2 y squared dx. Okay, y squared dx will be pi 0 pi over 2. Just square the entire thing dx. Then this will be pi over 2 0 e 2x cosine dx. Okay. Now take note of this guy here because the previous integral, which is e2x cosine 2x, not cosine square x. This guy from b is cosine 2x. This is cosine square x. Okay. So what we need to do is, of course, employ our favorite. From MF26, you have your double angle formula. We change this. We need cosine 2x. So cosine 2x. 2 cosine square x minus 1. So cosine square x is equals to cosine 2x plus 1 divided by 2. I'm going to just use this. Pi over 2, 0. Sine 2x plus 1 dx. Expand it. The 2, I bring it out. The 2, I bring it out. It is 0 pi over 2. Okay. This e2x is easy to manage. We know how to integrate this one. This is from part B. So you just write this down. I will do e2x. Part B. So the second is just normal integral, e2x. So I just group them together because boundaries are the same. So I'm going to replace it in. Just make sure your trigo is okay. So when you replace pi over 2 inside the 2x, it will be sine pi. Sine pi is 0. Cosine pi is -1. Okay. Then you replace pi over 2 inside, it will be this guy here. Then of course, you start replacing 0 is quite easy, straightforward. This is 0. Then the rest is just manipulation. You get this as unit exact value. E pi minus 3, holding bracket, all the way at pi away.